And fixed. That was fast. Let's see, we have music. Music. There's no music. Reload page. Start this. No. Yeah, I fixed it in the meantime. Relative to the previous stream, it was simply an uninitialized array. Where is my array? So yeah, the alpha is on the stack, not initialized. So it just contains random stuff. And the change I made is that if dd equals 0, I set it to 0. And this also got a little bit simplified because this used to be 3 minus the log 10 of dd or something like that. So if you blah, 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 that becomes I was actually equal to y. Anyway, so this is now the real formula, with which I'm much happier. Much happier. Especially that it doesn't change anymore between runs. You can delete this printing here. Yeah, the hood is also always 0, but okay. So this is the results. Pretty cool. Makes also a lot of sense, I think. This is the epsilon and belongs to this multiplication. And this epsilon belongs to this addition, which includes that part, so that's why it appears here. And then this epsilon, I mean also here, because, well, it's additional that part plus that part. That's why E4 appears here and there. And E3 is the multiplication. This multiplication. No, not this multiplication. It's the multiplication of xn times, actually the plus is without this. Huh? It's C2 plus C3 times xn. And then we multiply it again, and that multiplication has C3. And then the addition again, left and right. And then the multiplication. They always appear on the same spots. So the E1, E2 goes together. Propagates upwards. Yep. This is yeah, exactly what I expected basically. Well, I just wasn't really sure about it. But now I see it, I'm like, yes, this has to be it. Still not really sure about xi though, because I'm not even using xi. Tja, we're gonna see about it. Want to try the next one, that's the derivative. Going in the oven, so it's still not finished. Now it is finished. That was 2 seconds too early. Hey. What to do next? Let's go think about it. I guess this part, just this is what defines that it is a cubic. Nothing else. Isn't it? Hot. So that that's the derivative. I'm not taking the epsilon into account of the 3 times, I think. I mean, that is maybe 1 bit falls off if it's an odd number. So it's hardly stochastic something. Was already the last one. You have 2 epsilons less. Oh. So this thing runs over a lot more epsilons, but not all epsilons are used. So they should automatically disappear, yeah? If we just use the same evaluate queuing. Yep, you still get the exact same thing. This might not be correct, you would say. Because, well, it's an artifact of printing. Because I'm kind of assuming that every vector in front of every epsilon is 1. I'm not entirely convinced that would be the case here. That's kind of impossible even. I think there should be a factor of 2 in front of this, just, you know, as if C2 was doubled. C3 is tripled. No, what the heck. It still prints this as well. That's no good. Yeah, what? Yeah, that's definitely strange. The C3 in the derivative is multiplied with xn to the power 2. Which means that if I take the partial derivative relative to C3, we get 100th, 10th times to the power 2. It's 100th. So they should have asserted. Of course, I do have an assert for that. Time to print this again. See, there's a factor of 2 here. And 3. Why am I not asserting? I think I'm just rounding it off. Taking the logarithm or something? I think it's the extra 1/10 here is just ignored, just like that was ignored. That's not what we want. Still don't get it. DD30, 200. No way. Oh, fuck. It says equals. What? Yeah, that's not gonna assert. Well, why did I not get a warning there? Oh, because no, I should get a warning there. Should have gotten a warning. Hell, I am using everything, right? It is, yeah. I might as well just, and even that. Why am I using standard out? I don't know. Holy shit, this is not amusing. No. Okay, so if you have 1, then I want to use an I of 0. If you have 0.1, then you want to use an I of 1. Except that I don't for the derivative. See, my formula is wrong now. Here we assume that here being my sigma thing here, we assume that this index here is equal to that power, which is no longer true for the derivative. Yeah. It's only this nice formula because it's a polynomial, I think. And of course the derivative is still a polynomial, but then it's close. It's still only one power that has the coefficient. But eventually we could get really shitty stuff, I suppose. Where really, yeah, this could get complex as well. Some kind of formula of c's and powers of n, xn. And could do another summation, a third summation that runs over all the exponents of xn. To make it more general. Yeah, let's do that, as it were. The whole thing blows up in complexity, but now we have this working. It should be kind of explaining itself, I suppose. I do not have a subscript, I think, for... I have k. I don't have a superscript for k. I don't think so. No, the superscripts don't exist. No, I'm gonna use K anyway. Sure. Sum over k of something times x to the power xn to the power k. There's a space here. Let's put a space here as well. Cool. Now I put the k here at the end, so even though the summation comes first, you could just swap the summations anyway. But do whatever you want. But yeah, this becomes a standard array of the whole thing, comma, and then the power ons again to the size of c, which is then now indexed by k, right? And that means that yeah, let's run over it on the outside because of the way the sigma is. Although, like I said, it doesn't matter. We're still only calculating this double partial derivative to the and the way that it depends on k depends on if it is a derivative in this case or not, or basically this depends on the underlying function, whatever it is. But you can just calculate these values here and then calculate the partial derivative, print it, whatever. So the double partial derivative here is going to be a small integer multiplied with the root to some power, and that power is a maximum of 3, and the root itself is 0.1, 1/10. So it's going to be 1/1000 times a small integer at the smallest. So I multiply that with 1000 and you get 1/1000 of 100th of 1/10 or 1 times 1000 times an integer is still an integer. And then the rounding should definitely get us that. So maybe add a comment here. Desperately trying to find alpha, but oh, here it is. Some reason, no, not some reason. Undo, redo. So we took the partial derivative of this thing relative to that one and relative to that one. So what you get then is that times that. Easy peasy. Okay, so it gets slightly tiresome to scroll up and down, so just copy it from here. Integer, thank you very much. Maybe less than 3, but less than 9 would still work. So case 2, because it is 100th, so it is 1/10 to the power 2. And then the alpha ij, I guess. The k is 2. Here's 3. Minus 3. And the I and the j are just the things that we use to take the partial derivatives with respect to. And the question now is how to extract k and then how to extract the alpha, because you have to assign the alpha. Well, I would say if you take the logarithm of that and then round it, you probably get k or something. I should understand that from, let me think. Okay, so the logarithm with the minus sign is a bit problematic. Now the minus sign has to be removed. So we can do k as, we begin with taking the absolute value of dd. dd, where's dd? Oh, wait a minute. Now I'm talking about dd here. That's not what you want. Convert this thing to a double though. So I want to talk about this really. Double dd. I can just call it dd actually. We redefine dd. I think that was, the dd was that, and then later I multiplied it by 1000 and stuff. So now we're going to take the absolute value. Now we have the 0.03, and then we take the logarithm. But that gives us for 0.01, if it was exact, that would have given us -2, right? Let's add another example. More realistic. But less clear. So yeah, to get the k back, we can say, well, if it was all exact, then I would just take the logarithm, and then if I had, say, 0.1 to the power 2, I would get -2. So minus this would be k. And then if instead of 0.01, we was 0.1 squared, I would have a small integer multiplied with that. That would of course make The logarithm less. So I would have to take the ceiling of this. Wait a minute, the ceiling of the logarithm. Okay, the floor of the negative one. Or, oh my god. But there is a problem anyway, because it could have been 0.009999, which is slightly less than 100th. And that I still want to treat like 100th. Now, if only we had an AI that could figure this out. I'm going to prove that AIs cannot do anything by asking this to an AI. And you will see that we won't get anything here. Okay, so I'll try it. At least it helps with my train of thoughts, this expression. I don't understand this, but for the main part, no, it's not that bad. I was trying to go for just taking the log 10, but yeah, might as well do this loop here. Why not? Let's just use it. Decompose float. Whatever floats your boat. Names of in terms of naming, I mean. Okay. Oop. We don't have zero cases. Wait a minute. This value is less. Well, that's not going to happen, but it could be zero-ish. In that case, if it is zero-ish, then I just need to know that it is zero. I could return 0, 0, I guess. And what means that it is zero-ish? That does not mean that it's less than epsilon. That means that it is less than 1,000-ish to like 0.001. It's already good enough. I can even add a few zeros if I want to. Negative numbers, okay, we can remember the sign, we make it take the absolute value, find k by counting decimal places. So we're going to multiply value with 10. So if we didn't reach, well, say 0.9 should be seen as 9 times 0.1. Well, we are not having 9, but this is a bit vague because I'm pretty sure I said that 9 was allowed. But okay, well, it isn't allowed. Let's say the largest value that we can have is 8, so the 0.8 here. If it is less than 0.9, then it's actually 0.1 times some integer. So we still have to scale it up. And k itself should never get larger than 3 really, but okay, let's use 5 here. Don't know about that one because you already dealt with the 0 case. I could argue, or maybe it's going to be this. Small would still continue, well, although that wouldn't happen, of course, but this value itself would have to be multiplied by 1, 2, 3, 4, 5 times. And then we stop already. And then k is just way too big. Always use pre-increment, thank you very much. And then try increasing k, it just increases k, period. How can this ever be larger than this? It's not even possible, this, just forget about it. Add the sign back, okay, return k, very nice, except of course, what if this goes wrong? So, well, I guess I'll just add an assert, maybe. Or nah. I'm so not convinced. Okay, well, does this work or does it not work? Damn it. I think I'm just gonna print a lot of them. Shit, how to do that? Nobody's happy with this. It's too much. 50,000 lines to be manually checked. It doesn't work anymore. This is work in progress. the hell am I doing? So we switch to -4 the moment that we go here. I guess that makes sense because kind of should only, it should be -5 or -4, right? So this should just be rounded to the nearest integer. And again. And then yeah, 4999 or 0.5, I don't really care. And then we reach this, and now it's suddenly -9 times with the k is 1. Yeah, that looks good. And then here we drop to 8, 7, 6, 5, 4, 3, 2, 1. And then k is 2. Still slightly worried here about value between these values. Yeah, no, it works. I mean, if it is 0. Well, minus whatever, 0.091, then yeah, normally I should interpret it as a 9, but apparently it's interpreted as a -1 with the k is 1, which is yeah, yeah, okay. Okay, that seems to work then, right? So yeah, k becomes larger once more, and we get the same thing. And then here k even becomes 4. Yeah, but, well, this should really never happen. For the rest, it's the same thing, and then that is apparently the way it calculates 0 here. Then we return n is 0 and k is 0. That's good as well. And then we're going to do obviously the exact same thing with the sign, positive sign. Okay. It works. Alt2 and k is decompose float td. That's a smelly name, decompose. Where n is not used before, k is not used, I think. N is my alpha. Let's call it A. This is no longer true. Test it like that. Wait a minute. Uh-oh. Yeah, this is no longer working, is it? Or is it? Well, actually it is. Just a full loop. Sure. Yeah, what? I'm looping over K. I'm looping over K. But. What? Why am I looping over K? K is deduced. I should not be looping over K. Could have. Oh, that's a problem. We could have multiple K's, and then they are all encoded in this value. So the decompose is not good enough. Fuck. Anyway, this must be removed. We are not going to loop over K. Now, okay, in the case of the norm of the cubic and the derivative of the cubic, there is only one K. So this decompose is going to work. You can still test it for now. This returns just a single K, and that's going to be the correct K. But it returns only K equals 0 if A is 0, and we have to set all K's at 0. I mean, let's just face it, we have to set everything to 0. I might as well do that here, right? So before we even test this, let's say yes. So if A is not 0, then we have a single K that we can assign to. And now we can, oh, now I have to fix this part. What the hell is that doing? Oh, just printing it. Yeah, okay. Let's copy this again. My God, this is not easy. Okay, so differences before I did here. If I is larger than 1, we have to the power I. But now this is to the power K. And if that combination of I and k doesn't exist, then that would mean that all the alphas are non-existent. Well, they're all 0, so this is never true. Which means that so epsilon is not set. Which means that if epsilon is not set, I should not print any of this, including that. Well, that's easy, no? So if not so epsilon, then I just continue. Now we didn't print anything except this plus, which is then no longer correct. Now this prints only to the output stream, so I just drop that here, and then it works. If we saw at least one epsilon, then we print the plus. And if we need parentheses, if we saw multiple epsilons, then we do the parentheses, and then we print the output stream between the parentheses. And then we print the C with its index, that would be that one. Is it gewoon just per, should just do the whole thing, I guess, just, yeah. And then we do this, but the I here is of course K. Yes. Yeah, and then I have a K here. And now we need to loop over K as well. Well, let's do that slow, aka outer loop. That should be it. Run over K, run over I, run over J. And if any of those is set, we print a plus to the output function. Only if you already saw an epsilon. So print the first epsilon. You have multiple, my factor is missing here. So this is then alpha itself is the vector. I'm gonna do that nicely. That is, oh boy. If so epsilon, if not so epsilon, then we just have to print. Okay, I'm gonna do here, alpha is an integer. I'm gonna do A is my vector. And we print it here as a multiplication. Yeah, but I don't really want to print it when it is 1. Hell, I don't even want to print it if it's -1. It's so annoying. Sort of, but all of this is only true if we did not see epsilon yet, actually. That is all of this. And I might as well split them because I'm getting a headache here. No, not really, but you know what I mean. In a matter of saying. So we did not solve the first epsilon yet. That means that this is the first epsilon. And if the first epsilon, if the factor of the first epsilon is a 1, then we just print the epsilon. If the absolute value is 1 but it's not 1, then it's -1. So the first one is printed like this. Otherwise we print that factor. And we multiply it with that. So whether it's positive or negative, I don't care. And then in this case we already saw an epsilon. Then it depends of if we want to, if a equals, if a is less than 0, then, well, no, let's do it like this. If it is, it's not 0, right? I mean, otherwise we would not have entered here. If it is larger than 0, we just print the plus and everything is fine. And otherwise we print a minus sign. And I'm going to set a to -a, so it is now positive. And yeah, then we want to do the same thing again here with not printing it when it is 1. So we can just copy all of this, code duplication. That would be for which case? Everything, right? Yeah, but it's definitely going to be positive now. So this is just to check if a is 1, which means that this is true. I don't care about that one. We already took care of the minus above. Otherwise, yeah, I think this should do it. Core dumped definitely does not do it. Oh. Oh. I guess this is the problem here. Corrupted stack. Yeah, not a little bit. And that's annoying. Most logical thing is that they went over the bounds of alpha. That's something I really changed. And then the most logical thing is that this k here, it doesn't work really. It doesn't really work. Nope. Is this going to take a long time, or it did already print a lot, didn't it? Oh yeah, you can see that. I'll think about it. J is 8, J is 9. It's kind of weird though. I is 2 and J is 8. It's being printed. Three, 4, 5, 6, 7, 8. The nose is going wrong very soon. But where? Exactly. Guess I'll just keep running anyway. Yep, there it is. Evaluate cubic. No, okay. Break 135. Condition 2. What was it? I equals I've got 2 and 8 was it, yeah? 2 and J equals 8. Huh? Should have stopped. Oh, line 135. Yeah. Wait a minute. Delete everything. Okay. I wanted to have a breakpoint in. Where is my program here? 135 of. Yeah, of main. Just so. I don't know. Let's break in main again. Damn it. Run. Yes. Break 135. Condition 4. I equals 2 and J equals 8. Now continue. Now we are there. Print X. Well, I can't do that, but it is something. And C is something, and E is something. Doesn't really help much. Step. Now we're back in this line. It just worked. No, what the hell? Oh, wait a minute. This one still worked. This one still worked. So the next one doesn't work. So I have to remove the condition of 4 now. Just do condition 4, I think. Yes, now we can continue. Now we are now it's going to crash. So we can now at least still print these variables. Oh, that doesn't look good. No, that doesn't look good at all. If you compare that with the other prints, it's always That's the precision. Okay, yeah, the precision should have been 256. So xn is completely effed up. So then when did that happen? This still looks sane. xn is just a variable on the stack though. So it did get overridden, the stack, somewhere. Okay, so we set the condition back at 4, at I equals 2 and j equals 8. And then we run from the beginning. And then if we print xn, we see that that is still that. So we can print xn dot mp dot precision. And then the address to that. That looks like it was dereferenced. It's weird. No, I'm an idiot. Never mind. This is the pointer, yes. Okay, I just want to add a watch point now on this value. It should never change from 256 anyway. Watch point on the dereference value, of course, of that type, that address. Continue. Now it's 0. That's interesting. I mean, that's not what I saw. That was even worse. But okay, it is already overwritten now. And that happens here apparently. I'm writing 0 over it. So this is going over the boundaries of alpha. It's really strange. That totally should not be the case. What am I smelling? Probably nothing. Just a brain infarct or something. No, I'm just kidding. Blah, blah. IJK. Yeah, why is it overriding something? It's doing it here even. It doesn't make any sense. Something is overriding xn. The moment you write to alpha, but as far as I can see, all those indexes are sane. Unless they are not, of course. This should have a size of k, and k, the size of c, is on number of coefficients. That should be 4. Oh, Really? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ah. Am I wrong? Okay. Seems that alpha is declared wrongly or something. I added it on the wrong side. So I extended the array by wrapping an array around it, but it should have done it in the middle, in the inside. I think now that should run without crashing. Good. Now there you see the 2's appear. To exactly as it should be. The C2 has a 2 in front of everything. The C3 has a 3 every time. The C1 is now, because this is the derivative, the coefficient of xn to the power 0. C2 is that xn to the power 2 minus 1. And here as well, 2 is 1 less than 3. So that's correct. And since it's derivative, we begin with E6. And then the next one has added 2 of them, E7 and E8, and the next one has added the last one. So this is exactly correct. Yes. And if we turn all the derivative back to false, then it still works, of course. We get the previous result. Wait, I don't want to print that anymore. Neither this nor. And when that is the derivative already, that is source lines. Okay, make. Yep, so this is what we had before. Very good. Now also the derivative works. Yeah, I should go to bed. The next step is not trivial anyway. I have to think about it before I continue coding. Modified content. What is modified here? Oh yeah, allow not using add function. Yeah, whatever. For those who want to try it out at home. It's not radioactive, so you can safely do this. The product interval was something insane. I don't think I worked on that off stream actually. And source. Really? Standard range is missing. I mean, I did compile that, didn't I? That's probably just ranges. Why am I even clicking on this? It's ranges. Ranges there. Strange, however, that it's like that without compiling. I mean, I was trying to figure out a way to it's complicated. It's just complicated. And then I'm not even talking about what goes in here, which is the real hard part. So you have okay, we have two intervals within two values, which are two real values, which are in some interval. The interval is from A minus to A maximum, and the other one is from B minus to B maximum, the values being A and B. And if you multiply those two, then within what interval will the result lay? And I was hoping to be able to calculate that without having to do all four multiplications, all those four. And sometimes you can do that because if, for example, the minimum of B is larger than 0 and the minimum of A is larger than 0, and then of course the maximum is also larger than 0, then it's just the minimum is just the multiplication of the minimum of the two, and the maximum is the multiplication of the maximum of the ranges. So you don't have to multiply 4, you just have to multiply 2 of them. And that is in all of these cases. So by looking at the signs, you, in these eight cases, you only have to do 2 multiplications. But in the center here, when they both include 0, both A and B, then you have to do 4 multiplications. There's no other way, it seems. Anyway, did I change something? Oh yeah, I added ranges. Oh fuck, it's just a standard. See what I said? Exactly what I said. It doesn't assert. No, really, this whole thing is just asserts. If the asserts don't fire, then everything works. No, might as well add it, why not? So let's put it in Git. Git. Add product interval. And now gonna go to bed? Yes, but are you? Now I'm going to play chess. 10, 9, 8. Actually, I want to do this puzzle here. Puzzle of the day. So next Saturday I have to play external again. to, I don't know. Well, the thing wasn't even attacked yet. I want to protect my rook. I just want to protect my rook. He's going to attack my king in the meantime, so knight here. Oh, play. Checkmate! Now, okay, let's develop something else. What about this one? I mean, I'm a pawn up. What can go wrong? Let's develop this thing. I think this wing is done. Now we're going to play here. Just give check already. Jesus. She's still hoping to give mate here or something. He's defending it. He did not want to go back. I'm going to be annoying, maybe. Let's do annoying. You do this and then. And he doesn't have the bishop anymore. Oh, why not? It's like I'm a pawn up, so I'm going to exchange everything. I don't even have to develop. I don't have the castle. No, he doesn't know what to do anymore. The whole trap has been set. No, it's only waiting until I make that mistake or he can snap it closed. But what if I'm not going to make that mistake? Oh, there it is. Well, shall I take it now or always do this and lose a bishop? Let's take it now. And then let's try to exchange everything, including queens. I think the trap is moving this one and then taking this pawn back. Doesn't that make sense? So what if I move this forward? It's not gonna happen anymore then. Oh, what a beautiful bishop over here. Really beautiful. Okay, so now white plan is to play this pawn and then exchange it here and then open the rook. So I have to continue developing here. I would have, if I could put a knight here, I would do that, but no. It's not gonna happen, is it? Play, but that takes too long. By that time this has happened. So I don't want to, well actually I can't take back even. At the moment he takes, my queen is attacked. So my queen has to go. Without immediately giving up on this file. Where do I have to, I think my queen has to go here. Just let's move it. Maybe I can move the knight like this. So many moves. And I have to castle. I mean, you have to castle before move 10. They say, or move 8. What is it? There's the pawn, as expected. Okay, let's just develop a knight. This knight? Nah, this knight, because the rook really has to go here. But this knight is also nice. You can put a bishop here. But this knight could go here, maybe. Let's just use this knight to defend the pawn. And now he's going to take, of course, because there's a super bad backwards pawn that blocks his rook. He wants to get rid of it, so he's definitely going to take it. Which against me, a tempo on the queen. Ta-da! He's not doing it. Why the hell is he not taking my pawn? Takes this one. Okay, go away. He's doing fancy stuff. Why is he doing fancy stuff? I'm gonna go here or here. This is safer, isn't it? Well, he's giving away pieces. More material for me. Well, okay. Nobody gets this. I'm like, if you do this over the board and you look at my face, then you know that you have to give up. Like, what? Huh? What's going on? Then after 10 minutes, I'm mumbling something like, I really don't see it. Okay, now I'm +3. Che. All I want is exchange. What about this one? It's so annoying. Can I play this one up? 2? He takes en passant. I want to play this in castle. Queen is reasonably well placed over there. I'm going to go back. Oh, wait a minute. Then this one is a problem. Okay, I'm just going to develop this rook. Still not taking here. By now. It doesn't have anything on this file, so I might as well leave it closed. I have to move my knight here, and then I can develop my bishop, and then I can castle, and then they have a PS problem. So now do this, and he takes, and I take back. I do have an isolated double pawn, but on the other hand, the rook cannot be exchanged. That would be bad for him. So he goes, I win a tempo. Let's go for the double pawn. I really don't care anymore. I don't want to take myself. So if he takes, I exchange the rooks as well. How can that be bad? And then I take back here. See, it doesn't even do it. That's what I mean. Victory. Does the man has a plan? So he goes here, check, I lose my queen unless I can take back. This thing is protecting that one? No, the rook is 2. I can go there, I just exchange the queens. Nah. At most I'm running out of time. That's the only problem. He's thinking about exchanging the rook now or after this. Told you I didn't need that wing. Yeah, I'll just take it. I'll just take it. Oh, really? Could go here. Then I can go here. It doesn't want that, so he's playing this. But now I can go here, still preventing the bishop going here. So now the king comes here, and then I'm kind of going to lose a rook, it seems. Let's promote and get a queen. This one, I think. Yeah, now you get that. I'm gonna do this though. Couldn't have it. Get a queen. Oh, resigns. Okay. Yeah, I really should go to bed. I was going to do that puzzle of the day though. Looks nice, interesting. Oh, what happens? Little. You are black. Find the best move. I probably have to stop white from promoting. So if I can't move my pawns and I have to go here, then the white king comes there, and next time, next move they promote with check. I'm totally dead. I really have to make sure that I can't move with my pawns anymore, because I literally can't move with my pawns, and then white is to move, because then they have to do this and it's a stalemate. Or I just promote before they promote. Best candidate, this one. It threatens to promote, so he has to do something. If he takes, then I'm dead. Let's not do that. What about I do this one? Does it threaten anything? Maybe it threatens this one, I'm not sure. So let's assume he takes it. Then I play this one, which now definitely threatens to promote in 2 moves. Would that be soon enough? So suppose he just continues walking, and then I take here, and he takes there, and I get a queen, and I take. Oh, my mouse is scrolly. Don't scroll. I think this is the move. Yeah, he takes. I push this one. He has to take or push. Doesn't matter if he pushes a tick like this and I promote again, or he takes like this and I promote like that. I just promote. So I do this, he takes. I do this, he takes, for example. And then I just promote. But not on the same line as this pawn. So take, for example. Tuk, 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 tuk. Promote, go there, and then I'm still in time. It just stop scrolling. I'm gonna do this one. Yeah, and then this one, right. And now walk with this one. Definitely walk again. And that's it. I can't even finish it. Damn it. Computer thinking. Yeah, he's moving. I'm gonna get the queen. Is this a good, what it doesn't even try to promote? It's kind of boring, I think. Oh, wait a minute. Do I want to lose that pawn? Probably have to lose it anyway. Already lost it, as it were. Let's take this one. Some point you just get the idea that the computer isn't even trying anymore. It's literally not trying. Oops, I wanted to go one further. Mm.